All right, so we're going to take a look at the 1.4 homework, tangent line approximations. Again, this is one of the very first uses of calculus. All right, so first thing in all of these problems, or almost all of these problems, is we need to write the equation of our tangent line. And we know if we're going to write the equation of our tangent line, first we need to substitute in our x-coordinate to find our y value. Second, we need to find our derivative, so that third, we can substitute into our derivative to find our slope. Once we have those three pieces, we're able to write our tangent line. What we now do, or what we saw today in class, is now we substitute in the value we're attempting to approximate into our tangent line. It really is best to leave the equation unsimplified so that the arithmetic we do is pretty straightforward. So we substitute in the negative 1.9, we get 0.1, 75 times 0.1 gets me 7.5. I subtract my 21, and I get that y equals negative 13.5. As we discussed in class, the final step is you have to show that this is an approximation of the function. If you don't give your final answer as this, you lose a point. It's a technicality, but it's an important one. For number 3, I asked you to approximate what's happening at point 1. The book just asked to write the tangent line. But again, if we're going to approximate something, we're going to need our equation of our tangent line. So we're going to need our derivative. They've already given us the y-coordinate, so I don't need to substitute in to get that. I substitute in the x-coordinate into my derivative to find out what the slope of my tangent is, and I write my equation for my tangent line. I substitute in the value to be approximated, simplify, and then again, don't forget to show that this is an approximate. Number 5, if you want to use your calculator to get the trig values, that's fine with me. Just make sure that you are in radians. But again, if we're going to talk about writing the equation of a tangent line, we need our x-coordinate, we need our y-coordinate, which the book already gave to you. So now I just take my derivative, substitute into my derivative to get my slope, and I'm able to write the equation of my tangent line. This one didn't ask us to approximate anything, so we're done. Again, if we're going to write the equation of the tangent line, first thing we need to do is substitute into the original to get our y value. Second thing is take our derivative. Third, substitute into the derivative to get our slope, and then we're able to write our equation. We substitute in the value to be approximated, simplify, and then again, don't forget to use this final notation where you show that it's an approximate. Multiple choice number 1 wants us to say when the derivative is equal to 3. So the first thing I need to do is take my derivative. So notice I used my chain rule. 2 times e to a power, its derivative is just 2 times e to that exact same power, but then I need to take the derivative of that power. From there, I simplify my derivative. So I want to know when 3 equals my derivative. Well, the easiest way to do this is to graph y equals 3 and y equals 16x e to the 4x squared, and then ask the calculator for the intersection using second calculate and choice 5 intersection. The value is 0.168, so choice A. All right, hope this helped. If you still have questions, feel free to ask in class.